Hi Sai, hi Vanida, hi Bhupati, hi Amar, hello Virdi. Is somebody else trying to connect? All right, all right. So in last session, we were about to discuss Mahat, and then we said let's discuss it next time. So we will continue with Mahat, and all right. So we'll take one example of Mahat from end to end, and then we will describe what it is. All right. Sounds good. So guys, have you finished all your assignments? I see only few people have done it. Okay. So please finish your assignment because today is most likely last class and after this we'll only have a project. Okay. All right. So yep, let's move on. So we talked about various applications of machine learning. Machine learning has got lots of applications, and the good part is you do not need to be experts in various domains to come up with applications. Okay, machine learning makes it possible to to design a system without you having to understand each and every point of the data, and without you having to correlate every data. Okay. All right. So the general way of handling data and tools has been in this following manner. So machine learning tools come in various for various sizes of the data. When you have, I mean, this slide per se. So is my voice okay for everyone? Right. So when you have few lines of data and there is nothing much, you can do it. You can present, analyze the data using your pen and paper or the whiteboard. Okay, that's pretty easy. When you have like 10 data points or maybe 15 data points. But then when it goes to say few hundreds or few thousand, all right, when it goes to few thousand or maybe hundreds of thousands, then your normal tools do not help you. Okay, few lines of the data, your whiteboard, even Microsoft Excel can help you. But when it goes to hundreds of thousands, then you would require things like MATLAB, Octave, R for processing. Okay, but the moment the data starts growing and you have GBs of data, okay, GBs of online data, then you require things like Mahout and Giraffe. Okay. And between Mahout and R, there are other tools like NumPy, SciPy, and all of those things. Okay, but as a matter of fact, R and NumPy are used interchangeably for different objectives. Okay, but when we talk about big data, the Since all of the processing cannot happen on a single computer or even using a very, very powerful computer, then you need to distribute it. When the and for distribution of the work, Mahout is one of the very prime tool. Mahout, Giraffe, Amlib. Amlib comes with Apache Spark, and there is something called Graph X, which comes with Amlib. So all of these tools which are in the last row, their main and prime property is that they divide their processing. Okay, they divide their processing. They do not try to handle it on a single computer itself. They try to divide it on multiple computers. All right. These tools, Mahout and these tools don't say that we require few GBs of RAM just to solve a problem. Okay. Now let's take a recommendation example we had already taken. We have already discussed theoretically. Okay. So a recommendation means that based on the history of people, okay, let's say Sandeep likes Matrix, Sandeep likes Casablanca, and we have given this much of rating, while Kumar, some person Kumar likes Matrix and Shawshank Redemption, and they have given this much rating, right? Now, these are the three columns. So we format our data in three columns and give it to Mahat and say, hey, give us the recommendation. This is the data you wanted. Give us the recommendation. And the recommendation as given by Mahat is this. All right. All right. Okay. So there are many algorithms for recommendation, and the first one which I have given is similarity log lookalike. Okay. As I was talking about Mahat when I was describing, Mahat is nothing but a library of functions. Okay. It's a library. Okay. So in this library, there are multiple algorithms for generating recommendation, and one of those is similarity log lookalikehood. So these are various algorithms which various data scientists keep on building and contributing to Mahout library. Okay, and the difference between one algorithm and another is very mild, very small. Only in the specific cases of data you choose one over the another. Right. So like for example an algorithm called Tanimoto coefficient is good if you have Tanimoto coefficient is good if you uh, I mean if if you are looking for the similarities. Okay, say what it does, and the Tanimoto coefficient is little inefficient, but log lookalikehood is better, and then there are a few more cosine ones which are better. Okay, so let's take a look at it. How does it work? So person Sandeep and Kumar both watched movies. What is there would be similarity based on Sandeep and Kumar, right? So, how many movies Sandeep has watched? Two. And how many movies Kumar has watched? Two. And in total, they have watched three movies. Okay, if you take an intersection. So their similarity is quite high. So they are 1 by 3 similar. Sandeep and Kumar are 1 by 3 similar. So if there is another person, say Sai, so Sai would, if Sai has both the movies, let's say Sai has watched three movies, Matrix, Casablanca, and something else. Okay, so Sai and Sandeep has got a similarity index of 2 by 3. Okay, because okay, therefore, 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 the confidence of Sai being similar to Sandeep is quite high. Okay, so similarity index is like defined like this: that number of movies common between me and you divided by total movies which both of us have watched. So that is similarity index, and based on that, people are grouped together. Okay, based on that, people are grouped together. So there are multiple ways of doing recommendation. We can fairly switch between the one algorithm and another without worrying too much. Okay. Okay, so let's move on. Okay, so this is an assignment which was to be given in the last session. Okay, so please try to do this. Please try to do this, and we will also, I mean, go through one of the public data sets, and we will try to do a UG job. Okay. So this is important because your project is going to be similar to what we have described here. Import data from MySQL to Hive and back. This is okay. And point number two and three, build an Uzi job for fourth problem of session two assignment, which has multiple map reduces. And also, please go through the big data sets available on Amazon. Okay. And come up with the problem you want to solve. This will help us deciding the project. Okay. Now moving on. Okay. So again, we are going into Mahat's real example because here the real important thing is to understand how to use a particular Mahat's algorithm. Okay. Let me just log in onto the cluster. All right. So we have this. So this is the same data as what we have done earlier. And so you guys, if you have not downloaded, you can actually copy or you can directly use what I've already downloaded. These are basically 1 million recommendations from Movie Lens. Okay. These are 1 million recommendations from Movie Lens. If you remember, we had downloaded 100K earlier, and so you can do a wget and download these ratings. Okay, so I've already downloaded and it is located here, and the format of these movie ratings, who liked which movie, is of this format. Okay, so if you go into ratings dot dat, so you can see the movie id sorry, the person ID 1, movie ID 1193, and how much rating this person has given to this, along with timestamp. When was this movie rated? Okay. We don't have anything to do with the timestamp right now. Okay, but we need these first three columns. Okay, we need these first three columns, and to do that, first let's convert these ratings.dat to CSV. Okay, if we look at what are we going to use? Okay, we are going to use something called similarity log lookalike, and let's have a look at the documentation of similarity log lookalike. Okay, okay. So basically, okay. So once your text data is gathered, put it in text file separated by commas with no column headers. Okay. So that's what is the specification. So your test data, which has to have the three columns, okay, user ID, item ID, and preference, okay, should have no column headers and should be separated by comma. Okay. So let's say we have this. What should we do to in order to change dot dat into I mean change columns to comma? Anybody? We need to only pick up these three fields, remove double columns with comma, replace double columns with comma. Anybody quickly? So what we are looking for in the form of, we are looking for the data in this form, and what we have is right now this. Okay. What is it that we should do in order to translate this data to this? As you can see, 6040, 6040, and double colon. Instead of double colon, we want to replace double colon with comma, and so on. Anyone? All we want to do is translate our data, which is in this format, into this. So what we are trying to do is, in Mahat expects you to give user ID, product ID, and preference. In our case, it is viewer ID, movie ID, and rating. How much a person liked this movie, how much, at what time. That's what we have. And what we want is, we want to remove the last column and replace the double columns with comma. So anybody, quick suggestion to me? Amar, Bhupati, Sai, Vanaja, Virdi. If you're given this kind of a plain text file, so is my question clear to you? Hello? Hello? Have to use regex, but I don't know the command. Okay, okay. Okay. So, okay, Bhupati is saying that have to use regex, but I don't know the command. Okay, anybody else? You're very close, Bhupati. Just think about the command to use to replace things. Okay. Okay, then let's move on. Okay. So, okay. So, in Unix or in any of this, so there are multiple ways to do it. There are multiple ways to do it. There are multiple ways to do it. First, using a simple command of Unix, such as cat my file and then pipe, simple command of Unix, simple command sed of Unix, and then we say substitute this with that. Okay. And before that, if the data is very small, I will actually use a text editor. Okay. Text editor and replace. All right. Now, so do I need to increase the font? So sed command basically is also quite powerful. So you can say sed and then s and then say replace this, okay? Replace this with that, okay? So that is what it does, all right? Now, second is use, now if the data grows big, if the data was very small, we could have just opened this file in the text editor and just replaced it with Control F. And I'll show you how, because you have anyway attended my. So let me just say that we have this data and we want to replace it with whatever we require. So we say beginning of the line and we say anything and then double colon, then anything, then double colon, and then this. All right. Now we have this. Now we can say first one, comma, second one, comma, third one, right? And we say regular expression and we are done. Okay. You can try the same thing using added plus, or you can try the same thing with, uh, say Notepad plus plus. So edit you can try with Notepad++. Okay, it's a nice editor on Windows. Okay, on Mac you can try Sublime. Okay, okay, and on Linux you can try VI or there are other nice tools. I don't know much about that. Okay, there are gedit actually. Yeah, that's good. Ginny. All right. So you can try this the way I just did. That is good if you have few hundred kbs of data or maybe few hundred MBs of data. Okay. But if you start going into GBs, a Unix command matters. If you go into hundreds of GBs, then you have to make it a Python job, Python map reduce job. Okay. Map reduce job. And Python map reduce job looks like this. Okay, Python MapReduce job is, say I'll do my, what do you call, Hadoop jar, then streaming streaming.jar. Here's the whole path will come as we had discussed. Okay, and then some version, and then I'll say my mapper is going to be this command. Okay, that's all I'll do, and there'll be no reducer, nothing. And input file is this, and output file is all right. That was second approach. Now let's think about a third approach. You can use pig. Okay, you can use pig, and you can say load data. Okay, you can say x equals to load my ratings dot dat using pig catalog, and you can say colon. All right, this will load your x. Okay, and then you can say, okay, then you can say dump, what do you call it? There is the command was, I think, save dump. I forgot that pig command. I'll have to go back to the slide. So you can say dump x using pig catalog, and here you can say comma. Okay, so this will give you a comma separated file. Okay, so these two approaches are equivalent. Okay, if you have few MBs, this is good. Few GBs, this is good. And if you have greater than few GBs, then okay, few MBs, hundreds of MB to few GBs. Okay, few GBs as in 1 GB. All right. If it is 100 beyond 1 GB and you have to do this replace, then this is better. Are you guys with me? All right. So these are the four approaches. Okay, 0, 1, 2, 3. These are four approaches you can use, and probably you will find this one more easy, and you should try your projects with this pig command. Okay, and also in pig itself you could do use pig streaming. Okay, where you remember when we passing your data through a Unix command. Okay, so your Unix command and regular expression came into use at three places. First one this, second one this, okay, and third one this. Okay, so learning Unix goes a very long way. All right. Anybody else? Any questions so far? All right. So right now we only have a small file. Yeah. Okay. Now we'll have to copy it to the drive there. So Let's see what is there. Hadoop fs minus ls. Okay. Okay, let me just make some notes. So we already have copied ratings.csv. So what we did, let me just say, so we have ratings.dat, cat ratings.dat, and then what we did was we did this. Okay. So what I've done is I've used an awk command instead of sed. Here, here. I mean, there could be another third way where we can say that. Okay, like this. Okay. Now, what does it do? It basically splits the input by double colon. This is my split field, and then convert that into comma separated one. And after you do this, you'll get. Okay, so it's doing it. Now we have got ratings.csv. Is there any confusion about these commands at all? Okay. Is it clear to all? Because remember, you will have to do all of this as part of your project. If you have any doubts, raise a flag now. Ask questions now. Okay. Now we have prepared our CSV, which is comma separated file. Okay. So Bhupati, in case you get confused during labs, just give me a buzz. Okay. And let's also see what can be done to avoid and fast pace your labs time. Okay. So what you could do is you could come online when you are trying. Drop me an email that you will be online at that time and you want to start your labs before say 10-15 minutes. And then when I'm online, then you keep on working and chatting with me. Okay. In case you get stuck, I'll just immediately look at the logs and look at your screen. Okay. All right. So we have this. Now, once we have done our preparing our rating.csv, we can do Hadoop fs copy from local ratings.csv to my ASCII directory in the Hadoop file structure. Okay, it says ratings.csv exists, even better. So we already have that one. So, but you can use this command in order to prepare this. Okay, make sure you do that. Okay, let me see what does my Java home say. My Java home is empty. So now is the actual work. So we have to execute this command called mahat recommendation based minus s similarity log likelihood. Now it is not Hadoop command. Okay. So Vanaja's question is, can you please show me the, basically I used this command right now. See the last command? This is the command I used. My cat, my file, will read this file and give out the data as to next command in the pipeline. This is the pipe. I mean the separator between one command and another. So whatever content of the file are there, it's fed to this command. Okay, it's fed to this command, and whatever output of this command is there would go into a file called ratings.csv. That is this redirector is doing. Okay, and this command says that split my input using double colon and print $1, $2, $3. $1, $2, $3 are the placeholder because of the splitting. Okay, so this is the command. All right, Vanaja. Now the most important part is this. Let me. So this requires Java Home to be available in the environment variable. Okay. So Mahat's recommendation here is basically we are calling Mahat instead of Hadoop, if you notice, because it Mahat will be executing all map reduces by itself. Okay. You have to instruct Mahat that this is my file, this is the algorithm I want to use, and this is what I'm requesting. So here I'm requesting Mahat to run my to give me recommend which are item based using an algorithm called similarity log lookalikehood with an input file and output file. Okay. Okay. Now, so here we go. It might take a bit of time. Okay, and also give you an error in the beginning. Let's call it, okay, what is the date today? 29th November. Okay, 29/11. And so basically it will run your data on the CSV file and will give the results in the 29/11. It might take a little bit of time. So it says that this folder already exists. Okay, let me just delete this folder. So these are the previous records in the when we earlier ran it. So this is the format in which it gives you the output. These are the recommendations generated by Mahat. Okay. Here it says that give this user these recommendations. And what does this square bracket has? It has movie ID colon how much strong recommendation it is. Okay. It is that one. But if you see there it's all 5.0, 5.0, 5.0, 5.0. Can you guys see it clearly? No. But in this case, it is starts with 5.0. This is the most strongest movie. This person should definitely like this movie, but this person will not like this 3515 and so on. Okay, and so it's taking some time. It will actually run for quite some time because it prepares a lot of indexes. There's a boot up time involved. So since I'm using the same account, so probably it's creating the temp folder for all. So maybe you can try on different times. Okay. No, actually it creates a TEMP folder which is shared with all. And that's where it gives an error. Okay. I'm in process of creating separate accounts for everybody. So probably life will become easier then. All right. So this is the kind of recommendation you will get. So is everybody clear on how to build recommendations? Now, given a website like Amazon, okay, let's imagine for some time. So we for creating a website like Amazon, what we require for recommending products. Recommending products is quite fairly straightforward process based on similarly based on the user's history of visiting things. So what we can do is people who rated this also rated that. Okay, which means so we are given person 1, sorry, user 1, and we are given ratings 1. Okay, and we are given, sorry, user 1, product 1, and rating 1, using which you can say, and you have given this data. Okay, so you can, using this you can say user 1 recommended product 1 and how strong is recommendation. Okay, so this is what you can generate immediately. Strength of recommendation. Okay, similarly recommended product 2, and so you can generate this kind of data immediately using this, right? Similarly, on the same time, you can also give recommendation like people who visited this page also visited that. Okay, would like to visit this. How would you do that? So what will you do is user 1 visited page 1 how many times? Say 1,000 times. Okay. Say you have got user 1, user 2 visited the same page say 20 times, and so on. Now, first of all, you'll have to normalize it. You'll have to normalize this data to make it in the form of user 1 page and then you can say 5, right? Say we have got. So if you are not, okay, so you'll have to normalize the data in that form first to bring it down the ratings to 5 dot within 0 to 5. Okay, and how would you do it? So the general way of normalization is compute max of page. Okay, irrespective of compute max of each page. Say max of each page came out to be this, and then you do a basically normalize. Okay, and then you say use one basically whatever per page maximum you have defined, you have to do a division by that number. Okay. So now while recommendation, it's actually running and it might take quite some time. It forms lot of data. If the data increases slight bit, it doesn't impact this time because this is the common thing it has to do all the time. Okay. All right. So there we are. Let it run for some time. At the end of this process, it's still running. At the end of this process, it is going to give you this output as we just displayed to you using UI. Okay, there are other recommender algorithms are there. So whenever people say collaborative filtering, recommendation engine, recommender, all of that is the same thing. Okay, when somebody says that you used recommender algorithm, so your first question should be that which algorithm did you use? Did you use log likelihood? Did you use Tanimoto coefficient? For example, I used Tanimoto coefficient at in my past. Okay, so each one has its own benefits. Go through the details if you are interested. But in most cases, either cosine is good for you, log likelihood is also good for you, and Tanimoto coefficient is good for you. They all expect the same thing, similar input data. Okay. As we told earlier, that Mahout can be used other than collaborative filtering. You can use it for clustering. Clustering takes items. Okay. Say for example, if you see at Google News, it automatically clusters articles together, right? So that is clustering. Clustering is generally un not I mean non uh, you know what do you call non-assisted training. It is completely automated, and classification is you give that give machine learning algorithm that this particular item belongs to this category, this particular item belongs to this category, and now categorize rest of the items. Okay, that is another thing. So to generate recommendation engine, first you had to do is build CSV format such that all IDs are numbers. Okay, and remember that if you read one of my blogs where I had said that it actually took a lot of effort to convert my input to a format which is where product ID, user ID both are long, right? Long as in bigger integers. Okay, while my input, the input given to me, the input which I had extracted from Apache logs, the user ID as well as product ID both were big strings. Now I had to convert that into long. Similarly, all I was given is Apache logs. Now you need to convert those Apache logs into, first, sum up each value, build up how much a person likes something, or how much a preference a person is having, and after that you need to normalize that data, and that takes a little bit of effort. So most likely pig will suffice for all these use cases. Pig will be the best option when you are doing all of the churning. In case pig doesn't suffice, do quickly write a map reduce and get it done. Okay, so whatever today I had done using SED, you guys should try it out using pig. All right, you guys should try it out using pig, and I had given you a lot of hints here. You could basically use pig catalog, and then you can dump the data using pig catalog. Okay, should try that out. And also, once ratings are done in this format, you should try to convert these ratings, okay, such that using pig, this can be done very beautifully using pig itself. Using pig to basically convert this number into the name, convert this number into the name. Okay, okay, so these are the other algorithms. That is fine. Let me have a look. Yeah, it's finished. So we had saved our output in Asgiri Records 2911. Asgiri Records, not Asgiri. Is it in Asgiri Records? Uh, 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 okay, Asgiri slash Records 2911. Okay, here you can see Asgiri, and then we have Records 2911. We have this part. It's the same data. All right. Sounds good to you? Should we move on? All right. All right. So whatever I had done, you can actually do everything using your pig commands. Okay. And now once you have these recommendations generated, you generally dump these recommendations back into your relational database. Okay. You generally dump these recommendations back into your database because when you are generating recommendations, the input data is quite huge. Okay, for in my case it was 200 terabytes at in Mobi, and it was bigger at Amazon. And when you are putting it back into MySQL, the data is actually small. The ratings are hardly 1 GB. The ratings were hardly 1 GB in size for me. Okay, so you can basically dump this data back into into relational database. And you can use your J2E application or whatever application server you're using. There you can use servlet or whatever to read this data and present the recommendations to the user. Okay. In our case, we had to give this data in a thrift file to our ad ads in Mobi ads engine. Okay. They would load this data and then serve to the users. Okay. So you can use, so basically what I'm trying to portray is, although this is a batch process, this recommendation engine a batch process, you cannot say that when the request comes from the user, then generate the recommendations. This is a automated process which starts every day in the night or every time when every periodically. It cannot be on demand. Whole recommendation process. Okay. Sounds good. So let's move on then. So if you have any doubts, okay, after this, you should actually try to do all of this by yourself from end to end. Okay. Given a CSV file, so given a column separated file, how would you generate this? And also, how would you normalize your data? Okay. Good. Good. Moving on. So we talked about Hadoop so far. So some people found Hadoop little more constrained and little slower. Okay. Constraint as in whenever we write anything, we have to write using MapReduce. That's the only construct we have. Okay. So you write your map and reduce function, hand it over to Hadoop, and Hadoop will be executing those functions. So the control and command is under the hands of Hadoop. Okay. The data returned by your, basically, you do not, how should I say, Hadoop is mostly batch oriented. Batch oriented as in Hadoop will execute your job at Hadoop's will. Okay. And whenever it gets time, whenever it's free, and then it gets done, it returns to you. Okay. So some people at Berkeley, they worked at really hard to figure it out if they can build it a better solution. They did. So they built something called Spark. That also comes under now Hadoop's umbrella. Okay. So Spark is a great alternative to the traditional MapReduce engine of Hadoop. Okay. And let's go back if we can. Let's go back if we can to our first session. So here when we were talking about Spark, so Spark is a good competitor to MapReduce and both run on Yarn. Okay. Though without Yarn, Spark can run fairly well, but Spark runs on the top of Yarn. All right. So it's really, really fast than Hadoop. The focus with Spark is also in the in memory data. So if you have got great RAM, it will be even faster. It'll utilize your RAM to a very large extent. So if you have bigger RAM, then it will be hundreds of times faster. If you have smaller RAM, then it will be a little slower, but it's still faster than Hadoop. Hadoop MapReduce. Okay. So it has a similar paradigm of MapReduce, not identical, but similar. Okay. It is integrated with Hadoop in the sense that it runs on Yarn. And a little architecture diagram. So, as in components architecture. So, Spark Core has three dependencies. First, it can run as a standalone scheduler without running on top of another, or it can run on top of Yarn, or it can run on top of Mesos. Okay, so these are three alternative systems. So in case you want to install on a local machine, you can go ahead and download Spark and run it on your local machine. Okay, that will be standalone scheduler. Now Spark one is the core library, and then on top of Spark we have got Spark SQL, which is similar to Hive SQL, and Shark. Shark is basically similar to your Hive again. Okay, then you have got Spark Streaming. When you have to process a lot of data in real time, then Spark Streaming is pretty good. Okay. Then mlib. Similar to Mahod, there is mlib library which is very very similar and close to Mahod, just that there are few more functions. And then for processing graphs, if you have a lot of data in the form of graphs such as like Facebook or similar systems, then you can use GraphX on top of Spark. And these are good. These are doing good. Just that they are not, you know, they have not been in industry for quite some time, as opposed to MapReduce. Okay. All right. Now let's. So these were the components of Spark ecosystem. Now is uh, let's just discuss some concepts under Spark. The first one is resilient distributed data set. Okay, so this is an interesting concept from Spark. Okay, so in essence, it's basically a uniform presentation of data to all of the Spark nodes. Spark also has exactly similar concepts like multiple computers or multiple nodes. All of them have to see some data to do some operation. And the way they see the data is in the form of RDD, resilience distributed data set. Okay. So RDD can be persisted in memory, which means that RDD can be made available to all the nodes at the same time. Okay. And also RDD can recover from node failures. What does it mean? In case one of the computer fails, then basically each RDD will be running on multiple computers. Okay, one portion here, one portion there, another portion there, exactly the way HDFS runs. And the end user or any of the APIs who want to use RDD will be seeing it as a uniform system. Okay, keeping in the same spirit as HDFS, it also recovers from the failures. Okay, basically you can imagine RDD as a little bit different. And I'll describe it in more details. And RDD as opposed to HDFS can have little bit more structured data, and you can define little bit more data types. And RDD supports two kinds of operations: transformation and action. Right? So let me describe you this. So any file which is lying on file system, HDFS or anything, can be loaded into Spark in the form of resilient data set. So this is a mammoth data set which is running on hundreds of computers. But whenever a program or a user sees this data set, they think that this is a common singular system. Okay, they think that it's a common singular data set, a single data set. Imagine a huge table, few rows on this machine, few rows there, and everywhere. But when a user wants to access this data set, he sees the whole data set as one, because if it says next, 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 it can go keep on going to the next record till end. Okay, so that is the beauty of a resilience data set. And when this data set is there on all machines, we can do all sorts of operations on this data set. Okay, so the whole story of Spark starts with this data set. Okay, so there is this huge data set which is available to you, irrespective of where it is being stored. You get to see this resilience data set. Okay, now whenever you have to execute any work, there are two things you could do. Whenever there is a data lying on multiple machines, there are two things you can do. One, you can bring the data to a computer from which you're working and then process it and put it back, or you can send your code to these machines on which dataset is running. You can send your code to closer to the data. So there are these two things you can do, and each has its own benefits. If you send your code to multiple computers, there are chances that means that they will not be, these each components will not be able to use the processing done by other components. So piece of code sent to one, same code sent to machine 2, and same code sent to machine 3. All these three machines are storing the same data set. Same data set as in one portion of the data set on one machine 1, second portion on 2, and third portion on machine 3, right? Now you have two options. You read from all these three machines at a single location and do the job. Or you can send your work to all these three machines to do your work, process this data, right? To take care of the data locality. That is why Spark comes up with two kinds of works. One is called transformation, other is called action. Transformations are run on each different nodes, okay? While action brings the data from all machines to a central place for the execution. Okay, and the way you start the whole game is by loading the file like this. You say load my file into a variable called lines, and we call it spark context dot text file. This, we have a text file called data.txt. We want to load it as a resilience data set called lines. So lines becomes our resilience data set. Now, okay, now this is how the transformations look like. So there is something called a driver. Okay, so there is a driver node. Okay, this is that driver node, Spark driver application, where your code, when you say sc dot text file and this, that is, this code which you just wrote here will be loaded onto Spark driver application. So anybody who is connected to Spark is actually on the Spark driver node. Okay, we call it a Spark driver application node, where your script is loaded. Now this guy is going to command everybody, as opposed to the phenomena of MapReduce, where you did not command Hadoop MapReduce. All you did was you just launched a service from any node. Okay. Now rest of the process is taken care by Hadoop. Okay. Now what does RDD what does the RDD load the data from? Okay, where does RDD can load the data from the if you are running it on the top of yarn, it when and you say sc.text file and data.txt, that means it will load this text data.txt in hdfs. Okay, if you are running on standalone, then this file should be there physically on your file system. Okay. All right, Vidhi, was I able to answer? Good, good. Now, Spark Driver application would be sending the work to all the nodes which are running RDD, okay, without knowing, without specifically nailing down that this is the machine I want the execution from. Instead, in terms of programming construct, it will be asking. And that programming concept is transformation. So first form of transformation is say map. Map is a transformation as opposed to the map reduces map. Here it's a simple transformation which converts one data into another data. One key value into one key value, not multiple key value. Okay. Now let's have a look at this. So we say whatever lines we loaded earlier in the previous screen, we had loaded this text files, and this text files contains the lines. So each line we are saying count, we are saying lines dot map, and what is our mapper definition? This is our mapper definition. It says create a new function, and each new function has a function called call, and this call basically returns the length of the string. So what we are saying here is compute length of each of the line. Okay, this is what we are saying in this function. It's just the construct is little awkward. Okay, okay, and this is a format in Java. Those people who are actually familiar with Java will find the syntax little awkward because it's based on lambda functions introduced in Java 7. Okay, so those who have been doing programming in Java, they will also find it little intimidating. So those who don't know Java don't have to feel that bad. Okay, because everybody is, yeah. So basically what we are saying is define a new function called call and return the length. That's all. Okay, so this function basically run length computation at all the nodes. So go to node 1, compute length there, length of all the lines existing on node 1, node 2, node 3, node 4. So this is an example of transformation. So transformation runs on different nodes. The other analogy you can take of transformation and action is the transformation runs like map while action runs like reduce. All right. So here we have a transformation. There are many other different kind of transformation, okay, which are there. First one was map, as we gave you definition. So map basically returns. So whenever we do any transformation, each transformation results in a newer data. Okay, each transformation results in a newer data, which will be again on the RDD resilience data set. Okay, now whenever map is there, so whenever we execute map, you can look at the map as if it is Hadoop's map reduces map, or you can think of it as for each statement, for each statement of pig. Okay, whenever we had to do anything in pig of the sort like compute the lengths of each line, we did for each lines compute the length, right? So that was the that's analogies with pig and Hadoop MapReduce. Okay. Then we have another transformation called filter. Again, filter is similar to our filters in pig for each. You remember those? And group by, not group by. There are similar to that filter command. Okay. Now, so this also returns a new data set. So all transformation, just like our pig command. In pig command, whenever we say dump, or whenever we say dump, basically the action happens. Similarly here actions are different, and actions cause the execution. While whenever we write this code in script, it doesn't do anything. It keeps on distributing work, but it doesn't do the execution. Execution happen when an action is called. Okay. And transformation would run on all the machines exactly the way pig does. So, all right. Filter is one such command. So it will return a new data set which will match that condition. Okay. For the way we had written here a function, right? Lines.map do this. Similarly, we will say lines.filter and we define our function which returns true for our record. So this function we had defined here, call. Call will be called on each of the line in lines. Okay. Similarly, in case of a filter, the function we define will be executed on each line, which means that in case filter returns true for that particular line, only that line will be part of the newer uh, resilience dataset which is generated because of the output of this program. Okay, so each transformation results in a new data set, and that data set is again on RDD. And there are multiple ways to generate that data set. First is by using a function called map, then filter, then flat map. Flat map is actually more similar to the Hadoop MapReduce because a map above only returns the single line or single key value pair. Okay, single output per key. Per input line, it returns a single line, the first one, while flat map results in multiple output items on a single one, just like our MapReduce. Map in MapReduce basically gave multiple key values for single key value. Here it's a line, or here single data item. All right. And again, similar to our pig, it also has group by key. So whenever we call group by key, the group by key executes on the whole RDD resilience dataset. Okay. Now you can have a look at more kind of transformations at this location. Now the other form of commands to Spark is actions. Okay. Actions are what? Actions is something which causes the each of the node which are running RDD to return the output to the driver back. Okay. Earlier, whatever transformation did was whenever we wanted something to execute, let it execute and store it back on RDD. But in case In case we want to summarize all these values together, we would require we would require it to be executed on a single node, right? We counted length of each line. Now we want to sum up total number of lines, total number of characters, for example. Then we'll take the length of each line and sum it up. To sum it up, we require all of the data, right? And that's where the actions come into play. That's where the actions come into play. All right. So, so there are various kinds of actions. First one is reduce, other is count, other is collect and take. See, so as you can see that any reduce function always needed the whole data, not only the small proportion of the data. Similar is the case of count. We needed whole of the data. And then collect. Collect is another way we can just convert the whole data into a big array and do whatever we want to do. In case our code requires the whole data to be processed, in those cases, we might want to collect all the input into a single array and start processing on a single node. Okay. Now take n, return an array with the first n element of the data set, not parallel. Okay. Okay, so take n is like your tail command or head command of Unix, where we want to say, or limit of our pig command, where we want to say, give me the first five elements, last five elements, or so on. Okay, so more definition of these actions is available there. And before we go deep into reduce, let's take a 10 minutes break and come back and start. All right. Hi guys, I'm back. Are you guys back? Amar Bhupati, Sai Vanaja Virdi. All right, all right. So Amar and Bhupati and Vanaja are not there. Are you back, guys? All right, all right. Let me start. I think they'll join quickly. All right. So, all right. So we have got actions. So actions basically are good for the the job which requires all of the data together. Okay, so one of them is reduce and count and collect and take. So reduce itself and some of the actions basically try to delegate as much as job work to each of different nodes before bringing it together, right? So reduce is one such case which try to delegate as much as it can to the individual node and then summarize it together. Okay, let me just have a look at what. So, guys, if you remember, we talked about combiner. Who can tell me quickly what was combiner? Combiner in case of MapReduce Hadoop. Who can tell me quickly what was a combiner? Partitioner, combiner. So we're talking about combiner now. Anyone? Two jobs at the same time. No. Well, it is similar to two job at the same time, but give me a little more details. So in a MapReduce, we wrote a function called combiner. Remember, it has a similar definition like reduce, and it has all the functions which has certain property due to which they could be combiner valid combiner or cannot be. Like average or mean was not a valid combiner, while sum count was a valid combiner. Now, does it ring a bell? Vidhi? So, do you remember what was combiner in MapReduce? There was a combiner function. Average and mean was not a valid combiner, while sum and count was a valid combiner. Okay. So just like combiner, we have reduce function here. Okay. Here, reduce basically takes two argument and returns only one. And it has exactly the same behavior as combiner, which means it is cumulative and associative. The only difference between this and a combiner is Combiner took more than two values and returns 1. Here it takes exactly 2. Okay. Now here if you can see the again, so all first we did was we loaded our data onto multiple nodes. We said lines equal to load my text file. Okay, which means all these lines are loaded. Now after that we did in the second screen, all we did was computing the length of each line as existing on each node. After you do that, so all of these nodes, after transformation of the length, they all have lengths of each line. Okay, now when you try to do a combine, what happens? Okay, now if that imagine can you see this screen? This is little too small. Let me copy it somewhere and show it here. This will be better. Okay, so I need you guys to work with me in this exercise. Okay, so we had these lines in the beginning. We loaded these lines. Let's for time being we loaded it on a single node. Okay, single computer containing in memory an array of lines. Okay, it's pretty simple, an array of lines. Okay, now we computed line lengths. The sum would be, quickly, anybody quickly, what would be the sum here? So if you try to compute sum, so line lengths, you can imagine using a transformation, we converted each line into its line length. Or you can say that we have another data set called line lengths containing lines of each. The summation of line lengths, what would it be? Quickly, you need to work with me in this. 62. Great. Great. Now, imagine that the same work is delegated to multiple computers. Okay. There are three nodes, node 1, node 2, and node 3. On each node, there is a section of the data, not the whole data, section of the data lying. That is resilience data set. So this resilient data set called lines, when we say compute the line lengths, each of these is going to have 11, 9, and 4, right? The length of each of these lines. Okay. Now the total length, when we say total length on each machine, is going to be, I'll come back to this. Similarly, node 2 is having line length as 14 and node 3 is having line length of 20 and 4. All right. Now the next step is to compute total length. Okay. Now total length is being computed using a reduce function which takes two lengths, I mean two values and sums it up. So what will happen on this node is first total length will take these two values and will convert it into 20 and 4, right? This is okay? And in the next pass, it will just sum it up and give you 24. Okay? So in the first pass as in first summation, it only counted this, right? And then it counted both of these, and then we have 24. So node 1 says that line's length is 24. Node 2 in the similar way says my line's length is only 14, while node 3 says that my line length is 24. After that, the driver node driver node will get these total lengths from all these three nodes. And again, on driver node, we'll have three lengths: 24, 14, and 24. Now, driver node will again take two at a time, and will do the computation. Right? Now, question to you quickly is that if you had n lines, okay, if you had n lines, how many times, how many times your reduce function will be called? Okay, so as you notice that for say these many values, if it has to compute the the summation of all of this, what we'll do: first these two, then these two, then these two. Okay, we got three values after that, and out of three values, so in the first pass, okay, so in the first pass we call it pass, and line length, let's call it total length is 20, 18, and 24. Okay, and second pass, all right, second pass is how much? 38. Third pass, all right. So this is how a reduce function converts an array into a single value. Now question to you is, so in the first go, all it converted was a value of 3 into 6 into 3, then 3 into 2, and 2 into 1. In the worst case scenario, if you have n lines, how many times your reduce function will be called? Vanaja is saying n by 2. Are you sure? After you have converted n into n by 2, again it will be called how many times? N by 4 times, right? Yes, yes. So it will be the width is right. So after n by 2, Vanaja, it will be again called n by 4 times. And after n by 4, after you are left with n by 4 elements, it will again be called n by 2 times, n by 8 times, and it will keep on going, right? It is just like a binary tree. Okay. All right. It's a equal to height of the binary tree. It's an inverted binary tree. Yeah, you can look at it that way. All right. Any questions on this? So it'll be something like n log n. Okay, it'll be something like n log n. No, no, no. N plus 1 by 2 operations are actually done in the first shot itself, right? So it's n by 2 plus n by 4 plus n by 8 plus so on till 1, right? And if you see, so you can say that 1 by 2 to the power n plus 1 minus 1 divided by 1 by 2. Okay. Okay. I need to do a little bit computation. So, so generally the height of the binary tree is in the terms of the. Okay. So it's not really a height of binary tree. It's a height multiplied by nodes, right? So it's n log n actually. If you do a little bit computation, you'll come back to n log n. Okay. All right. All right. Let's move on. So this is how you do a computation. Therefore, the reduce function is not a great way. Reduce function may not be great for computing mean. You might have to come up with another idea. If you have to compute average, a better idea will be do a summation and then bring both the values to the function and then do a division there. Okay. All right. The only challenge with the Spark Only challenge with Spark is you need to be very cautious while writing your driver application. If you are not cautious enough and you do not utilize transformation and actions, you might end up doing everything on the Spark driver node. This is what I have seen in past. So most of the people actually end up doing all the computation on Spark driver application, because here on Spark driver everything else other than these actions and transformations it can be written, right? You can write a full Java program which is not utilizing transformation and actions, and that everything is being done in the driver application itself, and that's where the complexity starts. So if you do not utilize, so here it is up to you to utilize the transformation and actions. It is a choice to you. Okay. You loaded the data over there. Any operation on this data are going to be either transformation or action. In case you do action, you get a log variable which is not on resilience data set. And once you do that, any operation you do on that data, you will be doing on that particular node, not on the resilience data set. So therefore, you need to be very cautious when you do a operation here. Okay. Cool. So now moving on, other than these two big facilities, Spark provides you something more. Okay. Spark provides you with something called a broadcast variable. Broadcast variable behaves like a shared memory or a cache. As a lot of people ask when we discuss MapReduce, what if one map or reducer needs to communicate with another? The answer is generally using a third party central cache. So instead of using a third party cache, the Hadoop tries to the Apache Spark Apache Spark provides you something called a broadcast variables. Okay, in broadcast variables, what you have is you know a broadcast variable is basically Hadoop way, Spark way of sharing the data between multiple computers. Okay, so one node, whenever we say broadcast, one node actually broadcasts to all the nodes, and whenever we say get me the value of this particular broadcast, you get the latest value of it. Okay, so you can simply say create an array of elements and then ask Spark context to broadcast your variable. It will be available to all the nodes. Okay. Now that is broadcast variables. And on the similar lines of, yes, it is like the whiteboard thing that we talked about in last lecture. Yes, yes. So it is similar. Instead of utilizing something, having a zookeeper kind of system in place whenever you need to broadcast things between various hundreds of nodes, it by itself provides you a mechanism to broadcast. Okay. The other way of communicating is accumulators. Okay. Accumulators, the biggest challenge with most of the broadcast systems or most of the cache is the locking. And and sometimes you do not want you want only append only kind of scenario where locking is not required, right? In those cases, accumulators are really good. Okay. And what does the accumulator means? Every node is saying I'm giving you 10, I'm giving you 5, I'm giving you this, I'm giving that. So every node is giving out the value only. It's not taking in, right? That makes the whole summarization very easy. Also, in accumulation, the order of various values do not matter. Imagine that all the nodes are giving out the time taken for a computation. Okay, and the example which we just took about line counting, or say in real life, it's if all of these nodes are counting number of bytes being processed. Okay, and all of this gets accumulated irrespective of in which order the the data came in, whether node first, we counted the number given by the node first, or node 2 first, or node 3 first, in whatever order it comes in, it should not matter. Only then you should use accumulator. Okay. So accumulator is a programming construct provided by Spark, where it facilitates one way communication from nodes to the Spark application. Okay. I'm sorry. Yeah. So here, what we are trying to do is we created a accumulator with the default value at 0, initial value at 0, and then what we said was create an array which is parallelized. So now for each of the value, we are asking the nodes to basically accumulate. Okay, so all of the nodes will basically put their value as counter here, accumulator. and the value you get is 10. Okay, so whenever you have to do such one way communication where the order of various values do not matter to you, then accumulator is a great tool. Accumulator can be like statistics accumulator, or you can think of like all the nodes are sending debugging information to a central place. Debugging, not debugging information. Let's say the performance statistics being sent by all these machines. Okay, because in case of performances, it doesn't matter that we got the number one from one node first or second node first. Order doesn't matter. Sort of in the similar fashion, logging is also the same. Okay, we just take logs from all of these nodes and dump it in one place. So accumulator is a nice thing. An accumulator we generally use with numbers when we count them. It's a of one way data. Okay, all right. So that was Spark. Okay, that was Spark, and Spark is coming up really fast, and all the concepts which we learned about MapReduce are also quite useful in Spark when you do the actual work. Okay. Now the other portion, which is Spark streaming, is also really good. Okay. Spark's streaming, because Spark is really fast, and therefore Spark has been able to people have been able to use Spark for streaming. What does it mean by streaming? The meaning of a streaming is that when a data is coming live from a location, people are downloading it, people are pushing it, it's getting so streaming doesn't always mean that we are watching a movie. Streaming also means whenever you're downloading data, as in when we are able to download a record, we want to process that record. Okay, let me take a case of what I had been doing earlier. So whenever a user or a vendor is making a change in the data provided by them in on Amazon's product. So Amazon has got a lot of product. There are a lot of vendors, a lot of sellers. So sellers keep on making these changes. They change title, they change all kinds of. They keep on making these modifications, and all of these changes come in a central queue in a live as a live stream. Every millisecond, the changes are coming. There are hundreds of such changes are coming in a pipe that and we have to consume it. Okay, and based on these changes, what do we do? What we do is that we read one message by one message and then update various locations. Okay, so we have to update indexes, we have to update the photo, we have to optimize the photo. All of this pipeline keeps on happening, right? So this sort of job is a stream processing. Okay, while on one end there is a producer and other end there is a consumer. Okay, and all of them are have to work parallelly to actually be able to handle stream, and that's when the complexity starts, when you want to do it parallelly. Okay, now in Apache Spark streaming, as I said, that there's a huge pipe in just one example I gave. That pipe is Kafka, Flume, HDFS, 0MQ, or maybe some other modes. Okay. So on one end, there is these are the producers pipeline. The data is coming in via these pipelines. And on the other end, Spark can listen. Spark, using Spark streaming, you can read the data from these sources. Okay, these are the pipeline live data coming in. You keep on listening to these pipelines and keep on processing it. That is what is Apache the Spark streaming. Okay. And once you have finished with Spark streaming, you can store it anywhere you want. All right. Now let's take another example of stream processing. So input data came in, okay, and Spark streaming is reading that data. Spark streaming, instead of handling it in a millisecond, you might like to accumulate it in a bigger window of say few 1 hour. Okay, and this exactly is similar to the framework I built for Amazon, the example which I gave in. I converted the changes which were coming from the user in a 5 minutes fashion. Why? Because most of the changes that were coming from the user in that particular say 10 minutes window were actually pertaining to the same product. So a seller comes in, first it changes the title, then it tweaks quickly the description, and then again he goes back to the title and says, let me put the dot, and then keep does these 20 modifications in a minute's time, right? So so if we read in a window of 10 minutes or 5 minutes, we should be able to you know remove lot of duplicates from the input itself. Therefore, you need to convert most of these streams into the batches. Okay, into the batch you need to convert this into the batches. Okay, and after that you can process it howsoever you want. Converting it into batches takes a little bit of resources, but actually it is easier. Okay, so similarly Spark streaming takes the input data, converts that into batches, and sends it sends it for the processing. Now, and Spark streaming basically provides you a class in Java called dstream. Dstream is a continuous but discrete stream of data. As you can see, these are batches. That batches is something which is being provided by dstreams. Okay, so it has converted a continuous stream of data into the discrete stream. Okay, so how does it do it? How does it do it internally? So utilizing the same RDD, what it does is using whenever we feed the data to D stream, so we tell D streams, hey, read the data from this particular file. Okay, now D streams starts reading that file. It takes the it key, as people are writing to the file, it's reading to from that file. Just imagine that, or maybe 0MQ. So D stream is reading the data from one of these queues or files, and then internally for the data that came in between 0 to 1 second, it is stored on the RDD, and at a one particular section called at time 1, time 2, time 3. So it has got 1 seconds window. Okay, and dstream beautifully provides you the functions such as reduce by key and the window size. Okay, so that you can run the reduce function on a particular window rather than all the nodes or another way. Okay, so you can do a window wise operation, that to a distributed fashion. That is what Spark streaming or d-streaming provides. Now we'll take a simple service from end to end. We'll go across this. So before starting, we will create a Java streaming context. Okay. We basically create a connection with the name Java network word count, which basically has a window size of 100 1 second. Okay. This is duration is in milliseconds. So our you know our example has a window duration of 1 second. Okay. After that, we open a socket stream onto this context, which connects to localhost and this port. So that's where our lines are coming continuously from this host. Okay. Now we are basically trying to count the number of word count per second. Okay. As the number of words are coming in, we have to count them and count them parallelly. Okay. Now this is a simple example of running the streaming. Okay. Now here we got lines. Okay. Even though it's a stream, it's presented to you as a simple variable. Okay. Now all you need to do is lines.flatMap, the map which we talked about earlier. We only converted into uh, basically we converted into one word per line. Okay, that's what it. Basically, we had split it by space here. That's all. We have split it by space. Okay. Now, once we have this list of words, all we need to do is we need to form a pair of word and numeric one, just like we did earlier, and that we did using map function. So our map function basically converted each word into word comma one, and after that we can simply call reduce by key. Remember, so Hadoop's map reduces map is equivalent to flat map here, and Hadoop map reduce is equivalent to reduce by key here. Okay. Now once you do that, you can reduce by key. And how do we reduce by key? By providing a function which does the reduce two values summation at a time. Okay. So now when we say print, after this we'll be calling print. So after reduce by key, we'll get this word count. Word count is not in the RDD, it's a normal variable, and we can simply call print on that. Okay. Once you do that, you will get basically the word count of each second here, and then print. Okay. So that's how you do a word count example, which in which the words are coming per thousands of words are coming per second using using Spark. All right. So that was something called Spark streaming. Okay. So similar to the Apache Storm, there are multiple frameworks, and the more popular system for streaming job is called Storm. Okay. Apache Storm is fairly old and also does a lot of processing of real-time data. Okay. So a quick comparison between you know these two is Apache Storm can reliably process the streams of data. So basically, Apache Storm was invented at Yahoo, and a lot of people use it, and it's quite powerful and quite popular. Okay, the gains, the only difference between Apache Storm and Spark streaming is the biggest difference out of all is in case you are using Spark already, in case you are using Spark already and you have already distributed systems, probably you will not require Storm. Okay, but in case Storm is in case you don't have any other systems and all you need to do is for time being just do this stream processing, then Storm is a good idea. Okay. And there are lots of people benefits of Storm is that it is basically being used by many people. Okay. And these are the other comparisons between Spark and Storm, where in case of a storm, it is record at a time, and Spark, as we saw, we form the mini batches on the times. The latency, the return at the time in which it returns, is sub-second, while Spark is slower. Fault tolerant at least once, maybe duplicates. So what we are trying to do here is trying to compare Storm and Spark, and we realize that more fine-grained more fine-grained stream processing is still done by Storm. Okay, in case you do not require that precision, like precision of sub-second, or and you are okay with little slower process, then you can go for Spark streaming. In case you demand a really high throughput and the response time of less than a second, then you should go for Storm. Okay. So when your job involves pure streaming, then you should go with the Storm. In case streaming is not your critical part, then using Spark streaming is also good. Okay. Now let me compare quickly the NoSQL databases, so that when you are taking a call, so we just compared very brief the Spark and the Storm with respect to the streaming, and we realized that Spark streaming is also good enough in case you want you, in case you are okay with the second 1 second kind of latency, then Spark streaming is good, otherwise not good. Okay, otherwise Storm is better. Now let's compare various kinds of NoSQL databases available as of today, because you will have to take a call. This was done on a special request from the team in the previous sessions. They wanted to understand the various use cases of various databases and when to use them. Okay. So I'll be little rash, so that you can remember when to use what. Okay. So I'll try to brief everything in a single sentence, so that you do not get confused while taking a call on databases. Okay. Okay. And remember that this is just a very brief analysis. You should go into deep analysis if you are really planning to implement. All right. So let's so when somebody says we use Redis, what does it mean? Redis is an in-memory database. It's an in-memory database, which means if you really want to take the benefit of Redis, you will have to have lot of RAM. Okay. In case your data is beyond say 500 GB, okay, if your database in terabytes, then Redis doesn't help, because it keeps all the data in the RAM. And for being for crash protection, it keeps the data in the disk as well. But it doesn't keep partial data into RAM, it keeps full data into RAM. Okay. But it is really fast. Okay, it's 1,000 times faster than any other database when it comes to the processing of real time or complex data. The other benefit of having Redis is it because it's in RAM, so building a huge object is absolutely okay. So whenever you have to do complex data processing and in a really fast manner, even though data can be smaller, as in hundreds of GBs, as much as RAM you can support, you should go for Redis. Okay. So whenever you have a rapidly changing data with foreseeable I mean, with very small database size, then you should go for Redis. Okay. Examples are to store real-time stock prices, real-time analytics, leaderboard, and real-time communication. Okay. Redis and SAP HANA are identical in behavior. Okay. Not identical, they are similar. Then other database we'll see is in NoSQL is MongoDB. Whenever you have an object to be persisted and you are not in a pressing need of a relational system, you can go for MongoDB. It can act really well for the very highly structured data in the form of a complex, as in an object containing another object containing another object kind of systems. So there, the MongoDB really does well. Okay. All right. So CouchDB and MongoDB are actually competitors and basically compare to each other really well. All right. So in case your data is huge, data is bigger, it requires to be stored on multiple computers, multiple hard disks, and your data is complex in the form of pages. Then you would like to go for MongoDB. Don't use MongoDB for transactional data. And for transactional data, you should stick to the relational database. No, none of NoSQL can actually help you. Okay. Then Cassandra and HBase are analogous to each other, and whatever Cassandra can do, HBase can also do, and vice versa. The only benefit or added advantage of Cassandra is that it has got, you don't require HDFS to use Cassandra. You can independently start using Cassandra. Okay. Then comes HBase. HBase really excels well, just like Cassandra, when you have billions of rows and millions of columns. Okay. If you already have a Hadoop and HDFS stack, so probably you would like to go for HBase. Yes, MongoDB also supports MongoDB also supports MapReduce. Okay, in the similar structure but little hacky way. Okay, because for example, uh, the reduce itself has to the yeah. So there are minor differences. I can actually go into the details, but MongoDB does support MapReduce. Okay, the thing which it doesn't support is joins. Creating joining two collections of database or joining two tables is a very complex thing in MongoDB. Okay, so that is why they advocate to have uh, to combine most of the tables into a single big object. Okay, in HBase it's billions of rows and millions of column. Okay, and you can actually do a lot of things in HBase. All right. So these were a quick and very rash comparison of NoSQL databases. For details, I liked this particular URL better. You should go to that URL and look at that. Okay. All right. Now, tomorrow we'll be discussing more about your project. Okay. Tomorrow we'll be discussing more about your project, and so first of all, The way we have been doing projects is in the groups of three people. Okay, but today I think all four of you actually can do a single project. Amar, Bhupati, Vanaja, Sai, are you okay in doing a single project together, all of you? Awesome, awesome. And Virdi, I would like to assign you a different project. Okay. Your different project is basically, since we have already had discussion and you have already picked up something, I would like to assign you another different project. Or you want to you do the project with all the people and you keep your separate project for a long term. Okay. So the way we work is that all of you, I will send an email. All of you, I'll send an email in which the email IDs of all of you will be there in the two, right? So you can, after that, basically you have to suggest your own project. Okay, you'll have to suggest your own project, and based on that one, out of these all of you have to give at least two suggestions, and I'll go through your suggestions. In case none of you give the suggestion, then I will impose my ideas and I'll impose my project. I'll have no other option. All right. So give your suggestion for the project. And then what we will do is we'll have these frequent meetings of half an hour each for uh, next 2 weeks so that all of you coordinate and finish the project. Okay. Sounds good to you? Okay, so all of these meetings, project meetings, are going to be online. It is just that in these meetings, uh, if you have to say something, you will be unmuted and you can say. And for rest of the time, and all those meetings will be over the Google Hangout because these are three or more people. Okay, so first is go through these data sets. Okay, there are a lot of data sets available around the world to, or if you have any other project in mind, so please suggest please suggest at least two ideas for the project. They can be analyzing Twitter for the sentiment analysis, they can be generating recommendation from Netflix data or elsewhere, or they can be generating the product's recommendation, and it could be based on some classification of articles based on Mahat's classification. All right, and so there is no class tomorrow. Yes, yes, we can pick up sports. That's a good idea. Look at look at all possibilities and look at the things you know, a project which looks possible to you based on this knowledge of yours, what we have gained in these 10 sessions. Whatever looks possible to you, try to do that. Try to pick up a simpler one. Okay, simpler yet possible, as in the way we had given an example of what we do in case of a Mahat's recommendation. Okay, when you will start doing such kind of project, you will realize that it's actually a complex thing. Okay, it's actually a complex thing if you try to do it by yourself. Okay, so pick up, give at least two recommendations. All right, and I'll send an email to all of you right away. Okay, Okay. So project suggest your project. Okay. And go through this data, go through this data, and what will be a better what will be a better way of, yeah, it is okay to submit a project a little late, that's okay, but just keep us informed. Okay. And go through this data, or maybe your own ideas. Okay. Such, and few examples could be examples could be recommendation, or sentiment ana- sentiment analysis of a product. Then the other examples could be that Apache logs analysis. Right. So please think over it, give the recommendation. Also, okay. So suggest at least two ideas. At least two ideas. I'm not saying two ideas, at least two ideas. All right. Now, when will be the good time for having a half an hour discussion in the midweek? Thursday 7 to 9, or Thursday 8 to 10, or say 8 to 8:30? Half an hour discussion. This just have to be half an hour. Yeah, I think let's keep it in morning only. In morning, what time will work for you? Thursday, okay. Thursday is okay. 9 to 9:30? 9 to 9:30. All right. Oh, that won't work. 8 is also okay. It's just half an hour, Bhupati, so just 30 minutes. See if you can. 8 to 8:30? Bhupati, suggest a time then. Or do you want to keep it in the evening? I'm also even okay with the evening. Okay. Or what you can do is, Bhupati, that you give a. Okay. Okay. So suggest your time, and then we can have discussion on that date. And in the meantime, finish finish your all assignments, as well. Finish all the assignments, quizzes, and also finish. Uh, you know, submit them. And when you are doing a subjective examples, create a fresh Google Docs and share it. Okay. All right. Okay, then see you on Thursday or before or whatever date you have, and try to finish all your assignments and submit all of those things. And let's have a discussion in project discussion, and then we'll decide the approach and need to be done. Okay. All right then. Have a good day.